Students, this is Miss Sanders. I'm here to teach you a lesson on surface area and lateral surface area. By the end of this lesson, students should be able to answer these key questions. What is surface area? What is the difference between total surface area and lateral surface area? How do you find the surface area of three-dimensional figures using a model? And how do you find the surface area of three-dimensional figures using a net? Before we begin, let's recall some previous information. When we have a net, the net of a 3D shape is the figure laid down flat. It is the surfaces that make up the 3D shape. So here I have a square pyramid because the base is a square and it has one base. And if it has one base, it is a pyramid. And if it has two, it's a prism. So this is the square pyramid because it has one square base. The net of the shape is how we find the surface area because the net makes up the surface of the shape. And so to find this, we have to first know the names of our shapes and the names of our bases, and then we find the areas and add them up. That's simple. It's the same with a prism. This shape is a rectangular prism because it has two rectangle bases, and we know that squares are also rectangles. And to find the surface area of this shape, we would find the areas of each one of the bases and the faces, and then we would add them together. So where do you find this in the real world? Well, if I was going to wrap a gift, I am wrapping the surface of the gift or of the package, and so that would be surface area. Let's talk about lateral surface area and where you might see it. Well, lateral surface area, and that includes the shape that you've already seen, it includes the area of the surface but without the bases. So if these two circles are my bases, lateral surface area would only be the area of the rectangle face. Where do you find lateral surface area? Well, if I'm in a grocery store and I'm picking up a can, my can is labeled. And when I label my can, the bases are not labeled, only the rectangular face. So this is an instance where I would find the lateral surface area if I wanted to label a can. If I wanted to find the lateral surface area of another figure, it would be the same thing. This is very similar to the rectangular prism that we just saw. That's here. Again, the total surface area or surface area would be to find the area of the faces and then add them together. But lateral surface area, you do not find the area of the bases. So you would only find the area of the four faces and then add those together. So now, let's do some prior knowledge. I want you to look at your first worksheet, which is called Figure Match. The directions say draw lines matching the net of the figure, the name of the figure, and the three-dimensional representation of the figure. So I want you to recall the names, the nets, and the 3D representation. Pause the video and work on this worksheet. Okay, class, at this point, you should be done working on the worksheet by yourself. So let's check and make sure that you got it right. Miss Sanders would always tell you to shade the base, so I hope you did it already. But if you didn't and you don't know where the bases are, I'm going to help you out. So the base here is in the middle. It has one base, so that makes it a pyramid. These have two circle bases, And so we don't call this a prism, we call it a cylinder, because a prism has to have a polygon base. The next shape has two triangle bases, which makes it a prism. And the last shape has two rectangle bases. So the way that it can help you match the 3D representation is if you also shape the bases. The bases will be the same shape. Circles on the first shape, rectangles on the next shape, triangle, one triangle base on the third shape, and then two triangle bases on the fourth shape. So now I can begin my matching process. So the first one is a cylinder because of the circle bases and also the net representation. The rectangular prism, this is the 3D representation, and here is the net representation. My triangular prism, and we always want to look at that word prism because this has a triangle but it only has one, and one tells us it's a pyramid. So the triangular prism is here because it has two triangle faces or triangle bases. And then last, the triangle pyramid, which is at the top because it has one triangle base. Any questions? Oh, I'm sorry, I can't answer this because this is a recording. Alright, choose one of the figures above. Describe how you determine the name of the figure. Do that for me at this time. I am grading your papers even though I'm not here. Pause video so that students can complete the bottom section. Okay, students, the next worksheet that we're going to do is a little activity, and it's called pyramid measures. And so in pyramid measures, what we're going to do is you're going to cut apart your pieces of your pyramid net. You should have a sheet that looks like this. It might be a different color, but you should have 4 triangles and 1 square. So you're going to cut that apart at this time. Pause the video. Okay, students, you should have your pyramid pieces cut up, and this is what you should have. You should have 4 equal triangles or congruent triangles, and you should have 1 square. And I want to call this a rectangle because I haven't proved that it's a square yet, even though it looks like it's a rectangle. So what our next instruction says is that we're going to measure the height of each triangular face, and we're going to measure the base of each triangle face to the nearest quarter inch. We're also going to do the same thing for the square. Notice that the measurements are in inches. So I'm going to use my star chart, which you should use yours in your journal. And here I am measuring my square. My square measures at 4 inches. Turn my lamp off so you can see that. Okay, that's better. 4 inches. And I want to measure each side, and it looks like each side is 4 inches, so I can now call this a square. So I'm going to label my base 4 inches, my height 4 inches, same thing on the other sides, 4 inches. Okay, now for my triangle, the base of my triangle is also 4 inches, and because these triangles are congruent, I can assume that all of them should measure 4 inches. Okay. Now I'm going to measure the height of the triangle, and remember the height is perpendicular to the base. It should make a 90-degree angle. I'm going to draw my lines down the middle. To make a 90-degree angle, and this height is 2.5 or 2.5 inches. And so I can assume that they are all congruent. And if one triangle is 2.5, then the other ones are 2.5 or 2.5 inches. Go ahead and label. Follow me as I'm labeling. Okay. So now, with your tape, you're going to create a net. Can anyone guess what shape this is going to make? Hopefully you guessed a pyramid because it has one square base. So it's a square pyramid. So you're going to use your tape. And you're going to tape it. And you can pause the video for students to tape their pyramid together. Alright, I'm back and I'm going to tape mine now. Doesn't have to be perfect. Just make sure it makes sense. Don't tape this side on this side. Make sure it makes sense. Okay, all done. So now, if I wanted to find the surface area of this figure, I would find the area of all my bases or all my faces, and then I would add them together. So first, I'm going to do that on the back. Flip your square pyramid over, and let's find the areas. Well, we said that the square was 4 inches by 4 inches, and we know that area for a square is either base times height or side squared. I'm going to use side squared. My side is 4. I'm going to square it, which means it's 4 times 4, which equals 16 inches squared. Okay. My triangle, I'm going to find the area of 1 because I know they're all the same. So my triangle formula is area equals 1/2 base times height. And so I remembered that the base was 4, the height was 2.5. And I'm going to use PEMDAS, order of operations. Half of 4 is 2. And then 2 times 2.5 is 5 inches squared. So I know that if this triangle is 5 inches squared, I know that this triangle is 5 inches squared, the area. And I know that this triangle is 5 inches squared. And I know that this triangle is 5 inches squared. So now, I want you to calculate two things here. I want you to calculate the total surface area and then the lateral surface area. Remember, in the beginning, our definitions for finding the surface area, or the total surface area, which is the same thing, is to add all the surfaces together. So, total surface area, I'm going to add my base, which is 16, my face, and I have 4 faces. So I know that 5, 10, 15, 20, 26, 2, and 1 is 3. So my total surface area is 36 inches squared. We're still in square units because we're finding the area. We are not finding the volume. Total surface area is in inches squared or feet squared. If I wanted to find the lateral surface area, that is the area of the surface without the base. So at this point, I do not want the square. I only want the triangles that surround the square. Those triangles have areas of 5, 5, 5, and 5. And I can add all those together, or I can just times 5 by 4 and get 20. So the lateral surface area is 20 inches squared because, again, we're still in area, and area is measured in square units. Any questions? Oh, you'll have to ask me when I get back. Just playing. So now this says compare the height of the triangle faces to the height of the prism. Now this is where our vocabulary is going to come in, because there is some vocabulary that we need to know in order to find the surface area. So first of all, we know that area is the amount of space it takes to cover. So if I'm finding the area of this square, I'm finding the area of the inside of the shape here, which is 4 times 4, which is 16. The area of the base. When I find the area of the base, we know that that stands for big B. Big B. Big B, it looks like this. This is the area of the base. And when we recognize this from finding volume, when we would find volume, we would find the area of the base, which would be the center here on this particular shape, and then we would times it by the height. And we will find that in surface area, when we use the formulas, the area of the base is quite important. But for now, we just want to remember what big B stands for, which is the area of the base. So now, we want to talk about the height. And when we're talking about the height, we're talking about the height of the prism. The height of the prism or the height of the pyramid. And the height of the pyramid is that height from the center of the pyramid to the tip of the pyramid. That is your height. It's from the center to where the pyramid tips. Let me use this pyramid to give you a better demonstration. It's from the center to where it comes to the top. And that is called, your slant height is the height that you know, and that's the height of the triangle. The slant height is the height of the triangle. So on this shape, this will be the slant height, because when the pyramid is closed together, it is at a slant. So this is your slant height, also known as your L. And then of course, perimeter of the base. That is another key one. When you see the big P, you're finding the perimeter of the base. So remember these terms because they're going to come back up later. Hope you learned something. That's all for now.